I'm Joseph-von-Fraunhofer-Str, Head of R&D here at Pfinztal, and today I'm proud to show you some details of the V3 active transponders. So in this presentation, first I'll introduce you to the new lineup of transponders, then we'll go through the improvements comparing to the V2. Then we'll talk about changes. There are some significant changes on how the transponder behaves, and also we will look at new features. So let's get started. So for the new product lineup, it is important to understand that we have a new transponder in there. So now we have 4 different transponders. We have the basic, the Pro Performance, and Card. The Pro Performance is new. But before we go into details on that, let's talk about the basic. The basic has changed. The battery life has been reduced. Therefore, we now have a 2D antenna, making it useful for most events. And the price has been reduced. And what we're aiming for here is to have a transponder which can be used on events which have a high loss rate of transponders. So whenever you have an event where you need to use active and you lose a lot of transponders, you would run into the problem that the lost transponders are kind of a pain, especially financially. And therefore we wanted to create a product which caters to that market, and this is the basic. The Pro has basically not changed a lot. It is still the best product for most events. I would say it's the transponder that you should choose if you don't know why you should use any other. So the Pro transponder is the transponder of choice for 95% of all the applications. The Pro Performance is catering to the last upper 5%, where you have some special needs where you don't care that much about battery life. The Pro Performance is especially useful if you have live TV coverage and you want the absolute best performance, both timing-wise and also data-wise, speed of getting data out of transponders. If this is of your concern, then the Performance is the one to use. Important here is that you can even mix and match transponders in one event. So you could just have performance transponders on your elite participants and rest of the field is using pros or even basics. And last but not least, we have the V3 Card. It is catering to the special market of rental car tracks, where we now even refined the transponder tuning a little bit more to electric cards, making it even more immune to the electric cards' EMI noises. So let's talk about the overall improvements. Timing-wise, we have a better internal resolution now. The V2 and V1 transponders were operating on 1/256th of a second, basically 4 milliseconds. And the V3 transponders, all of them operate on a 1/1024th of a second, so 1 millisecond resolution. We have a new algorithm. I'll go into some details about that later. How the transponder actually determines the time over a loop. And this gives us better accuracy. Also, the store mode was significantly improved. The store mode is something that is typically used if you have a remote timing location. And in most use cases, you don't need a time down to 1/100th of a second in those scenarios. But sometimes you want them, and we put quite some effort into refining the store mode, making it even more precise. Every single transponder is now calibrated in production to give you maximum store mode precision, making it around ±5 ppm, which is quite good for the fact that the time is actually kept in the transponder. Now, another important improvement is about energy consumption. So the overall energy consumption of the transponder, if it's just sitting there doing nothing, is basically the same as before. Nothing changed there. But with the new technology that we're using in the transponder, we were able to significantly improve the power consumption or reduce the power consumption when the transponder is doing something. So for example, if it's sending out a track ping or recording a passing or when it's over the loop. And especially the over the loop case is important because we ran into some issues in the last years with transponders being activated for longer periods of time, basically draining the battery and being at the end of their battery life too early. And I don't know, maybe some of you know that the old transponder, if you put it on a loop and permanently activated it, you had about 5 days of battery life. With the V3 transponder, you can have up to 250 days of permanent activation. And that's a significant difference. I mean, no one will ever have a transponder over a loop for 250 days, I hope. But if you, for example, have your participant standing on the loop waiting for the start, typical scenario of road race cycling events, and there may be a longer wait period, multiple minutes, 20 minutes or something like that, it makes a difference. And we were able to significantly improve the transponder in those cases. With the improved battery life or the improved energy consumption also comes longer tracking. So with the Pro, we now can offer 1,000 days of tracking. So that's 24,000 hours of continuous tracking in the Pro. And I think this is a significant difference, which makes tracking applications much cheaper. If you divide the hours of tracking that you have in a battery, on the V2 it was kind of expensive to use tracking because it depleted the battery earlier. On the V3 it barely makes any difference anymore. I would say typically you will not drain your battery empty using tracking anymore. Another very important difference is the low temperature performance. And we went quite far here, changed the circuitry of the internal components to make the transponder more robust against low temperatures. And we hope that this will be a huge benefit for all of you out there doing winter sports, so that in 5 years from now, we are not discussing about the question of how full the battery is and if you can still use it in the cold. The transponder also saves its battery by doing something called an adaptive noise avoidance. One problem that we have is that if transponders are close to electric fields or in keyless go cars, sometimes they get activated all the time and this draws the battery. And the new transponder can now figure out that it is in such a situation, and the Pro will automatically dial down its sensitivity to cater for the noisy environment and therefore not deplete its battery when it's, for example, in a keyless go car. So let's look at some of the things that we just talked about, and let's start with store mode. Here I have a graphic showing the distribution of stored times with V2 on the top and V3 at the bottom. And what you can see is that the V2 stored precision is spread out over a larger time, and the V3 is compressed more. This is due to the calibration of every single transponder. We are not relying on the crystal quartz precision anymore. We actually calibrate every single transponder. And on the right side here, you see a drift that happened with the V2, which was temperature dependent. So at 0 degrees Celsius, the V2 after 8 hours had a drift of about 0.5 seconds, no, 0.5 seconds. And the V3 doesn't have that anymore because it measures the temperature and compensates for that. Now looking at the algorithm, I won't go into details about the algorithm, but on this picture, on the upper graph, you see what the transponder actually sees on its 3 receiver coils, if it's a 3D receiver. And then you see what the algorithm does. And in the middle picture, you see the orange dots, and this is basically the signal strength that the transponder sees. And the V2 and V1 transponder basically try to find the maximum signal strength, and this was the middle of the loop, and that's how they derived the time for the passing. For the V3 transponder, this is different. I won't go into details of how we actually did it, but we were able to significantly improve the algorithm, giving us better repeatable accuracy over the loop. Speaking about accuracy, another thing that was possible with the new technology was the question of how many delays or what kind of jitter is added to the data when it's transmitted over 2.4 GHz to the receiver side. And with the new technology that we're using in the V3, we were able to significantly reduce the jitter, and you can see this in this graphic here. On the left, you see the V2, two transponders being activated at the exact same time over a loop. And the differences between the two times those two transponders report. And on the right, you see the same for V3, and you can directly see that there is a huge difference. The V3s report much closer times than the V2s, and this is due to the jitter over the 2.4 GHz data communication. Now, the last picture that I want to show you is about the cold temperature performance. And what you can see here is on the green line, you see the battery voltage going down when the transponder creates a passing, because it consumes energy, it draws current from the battery, so the voltage goes down, and this is bad extremely bad when the battery is cold and the battery has a high internal resistance. And on the other picture, you see the new circuitry of the V3 in blue. You see a line which does not go down, and this line shows the voltage supply of the voltage sensitive part of our circuit, basically not suffering from the battery drop during a cold temperature passing. So now went into the details of all the improvements. Let's talk about the changes. As I already said, the basic is now a 2D transponder, but there are some more changes that you need to know to operate the V3 transponder, which are important. One is the store limit. We had several issues and events in the last years where people ran into the question of how long can you store a passing. So the longest possible time to store a passing. But on the other side, having unwanted stored passing from the day before, ruining your event because you get passings that you didn't expect. And to fix those issues, we reduced the time for stored passing to 12 hours. So typically an unwanted passing from the day before will not be ruining your event anymore. But also we improved it a little bit in a way that an intentional store passing, so a stored passing which is created by a store loop, lengthens the time to another 12 hours. So you can now do basically endless stored passings if you manage to have it over a store loop every 12 hours until the buffer of the transponder is full. But you can definitely do more than 24 hours now if you need it for whatever reason. Another change that is important to know is how the transponder behaves when it's over a loop. So typically when you pull a transponder over a loop, there is one passing created and that's it. The problem is when the transponder stays over a loop a little bit longer, V2 and V1 transponders create a passing roughly every second. The new transponder behaves differently here. The new transponder creates a first passing when you enter the field. That's your standard passing. And then when it's over the field, it creates another passing every 5 seconds, what we call a continuous passing. And this is indicated by a hit count, as you can see in the software, of 254. So if you see a 254 hits passing, you know it's a continuous passing every 5 seconds. And this is especially for checking whether something's going on. If you have people standing on the loop, you want the timing system to blink, you want passings to come in. But every 5 seconds is enough for that. And when the transponder leaves the field, it creates an exit passing. And this is new, because in the past, you had the problem that if the transponder leaves the field, basically the time when the last passing was created was sometime in the last second before the transponder left the field, but that was not precise. You didn't exactly know when the transponder left the field. Now the transponder will create an exit passing, which is precise down to 1/10 of a second. It's still not perfect, but it's much better than everything we had so far for start situations where you precisely want to know when somebody actually left the field. For tracking, there are some changes, some significant changes. The V3 Pro now has an adaptive track ping rate, meaning it saves a lot of energy by not sending out its track ping every second. It actually goes down to every 2 seconds after 10 seconds. So if it's in front of a track box, it sends out its track pings once per second, but as soon as it's not seeing any track box anymore for 10 seconds, it goes down to a track ping every 2 seconds. And then after an hour, it goes down to a track ping every 5 seconds, saving energy. It will immediately jump back to every second as soon as the track box again to give us maximum accuracy of the track box passing. But when it's just out in the field, basically not close to any of our equipment, it will only send out a track ping every 5 seconds. Also, the track ping range has been reduced, again to save power. Actually, we had many people complaining about track ping range being too far. So the track pings are sent at a lower power level now. This is important to understand if you use last year's setup. Typical setups with track boxes along a road will be just fine. And hopefully you will have much less stray track pings coming in than in the past. But there may be some special applications where you actually use long-range track pings in the past where you won't be able to do the same thing anymore with the V3. Another thing that we changed for tracking is that the tracking now stays on for 5 hours between track boxes. We had some customers having problems with that they were not able to make sure that there is a track box every 3 hours, which was the limit on the V2. Now you have 5 hours between 2 track boxes. And now the limit after the transponder in tracking mode wants to see a loop again has been extended to 25 hours. This was 12 hours before. And we had quite some customers running into issues there, especially in 24-hour races, forgetting about the fact that the transponder needs to see a loop once in a while. And therefore we now extended it to 25 hours, making sure that if you do a 24-hour race, you won't run into that problem. So after 25 hours, the transponder wants to see a loop again, otherwise it will shut down tracking. And now the last change about tracking, which is probably the most important and the most people were waiting for, you can now activate tracking by putting your timing system on loop 8, channel 8. So if you, at your start line, use loop 8, channel 8, it will activate tracking. This means that you don't need a second loop anymore to activate tracking. You can just use one loop, 8-8. This activates tracking on channel 8. The transponder will then go into a mode where it sends the first track pings 5 seconds later. So after activation on 8-8, it sends out a passing, generates a normal start passing, waits for 5 seconds, and it starts sending out track pings every 5 seconds. You then need to have a track box within the first hour of your event. So if you want to use 8-8, you set your loop, your start loop to 8-8, just generate your normal start passing, transponder activates tracking, have a track box within 1 hour, and then the transponder will just stay on normally for the next 5 hours for the next track box to come. So that was it for tracking features. Another change that we did is we actually now have a deeper deep sleep mode. So you can still enable the deep sleep with a management box, but now the transponder will sleep even deeper. And this is again for battery consumption reasons. We had some customers complaining about this, that transponders even in deep sleep were waking up especially from high noisy environments. And we wanted to be absolutely sure that if a transponder is in deep sleep, it's sleeping. So the deep sleep is now even deeper. And that brings a big difference in how to use the transponder. In the past, if you had transponders in deep sleep, you could just activate them by your start loop. Typical applications, you didn't have to care that much if they were activated or not, because the start loop was activating them in most cases. With the V3 transponder, this is different. The deep sleep is so deep that you intentionally have to wake them up with a normal loop, but close to that loop. So make sure that if you have transponders in deep sleep, V3 transponders in deep sleep, that you intentionally activate them, get them out of deep sleep. You have to wake them up before your event. On the other side, putting transponders into deep sleep and waking them up, as I said, doesn't take that much energy anymore because the energy consumption of the transponder when it's doing something has been significantly reduced. So you can now put it into deep sleep much earlier, more often than you've maybe been doing it in the past. Basically, you can do it in between every event if you want. So, last point that I want to discuss in this video is the new features. The V3 has some new features that were not present in the old transponders. And the first new feature that I want to talk about is the quad channel mode. This is a new feature introduced with the performance version. So this is only in the V3 Pro Performance transponder. It has a quad channel mode. Maybe some of you know our transponder from V2 on always had a main and a backup 2.4 GHz channel. And whenever the transponder tried to send out its passing, it tried first on the main channel, and if it couldn't get its passing through, it tried on the backup channel. And in 99.9% of the events, this is perfectly fine, works well. So, but if you are on a high-profile live TV event and you need the lowest latency for the passing data to come from the transponder to your timing system, you can run into problems if the transmission on main and backup line does not work at the first try. And especially if there's a lot of 2.4 GHz stuff going on with live TV cameras and things like that, you may run into problems. And we acknowledge that and say, okay, for those special applications, especially for elite participants on elite events, the quad channel mode solves this problem, because what happens with the quad channel mode is that the transponder tries it on the main channel, then tries it on the backup channel, and then it goes to another channel and there again tries it on main and backup. This means that we in sum have 4 different channels that the transponder can use to get rid of its data. Now you may ask the question, okay, how do I receive the data? Basically it means you set up a second box on the other channel. And now how does this work? It works as follows. You always have pairs of channel. So channel 1 and 2 form a pair, channel 3 and 4 form a pair, channel 5 and 6, and 7 and 8 form a pair. Now, so let's say you have your main loop on channel 1, then you may even have a backup loop on the ground on channel 2, and if the transponder does not get its data through to the first box on channel 1, it will automatically try on channel 2, and if from the backup line the transponder does not get it through on channel 2, it will automatically try it on channel 1. So this should be an absolutely bulletproof solution for those very rare occasions where you need the absolute lowest latency and have a very noisy finish line situation. For those applications, the Pro Performance is the best solution. So the last 2 new features actually do not only apply to the Pro Performance, they exist in all transponders. And one we call the extra code, and the other one we call a key value store. Let's talk about the extra code. Extra code means that you can put your own transponder code into the transponder, and that transponder code that you put in the transponder is reported with every passing. The code that you can put into the transponder is a number between 0 and 32,000 or A0 to Z1000. And this can, for example, replace your chip file if your transponders report the same their chip file encoding. We will see what you can come up with For example, for karting applications, you can encode the card number into that transponder, and then you immediately in your software see the card number instead of some transponder code. So this is the extra code. The other thing is the key value store. The key value store means that we now have memory in the transponder that you can freely program with whatever you want, and you can also read it out. And with that, we hope that you come up with interesting ideas of what to use it for. You program it with a management box and you read it with a management box. And it could, for example, be used if you have personalized transponder to have some identification of the participant stored in the transponder, like a UCI ID. Or you could also store the owner of this transponder in that memory. So if you rent out your transponders among each other, for example, and you want to know where does this transponder belong to, you can read out the owner field. In total, we have 20 fields with 80 characters for key and value, which gives us plenty of memory to do interesting stuff with it. And we'll see what people come up with, what to do with this. There are some interesting ideas, and I'm looking forward to that. So this was it for all the improvements, changes, and features. I hope you like what we did with the V3 transponder. There's one last thing that I wanted to show you is how can you actually see that a transponder is V3. It's not absolutely crucially important to know because they're all compatible. You can mix and match transponders V1, V2, V3. You can use V3 with all our existing equipment. But still, sometimes you easily want to determine whether a transponder is V2 and V3. Obviously, it says V3 here at the front, but there is a significant change that makes it easy to determine whether it's a V3, and this is the back. All V1 and V2 transponders had a white potting material. The V3 has this dark gray, and this makes it very easy to see whether it's a V3 transponder or not. So this was it for the presentation, detailed presentation of the V3 transponder, and see you next time.